Okay, today we're going to solve rational equations. So what we've been doing up until now has been always an expression, and now we're going to actually solve an equation. I think you're going to find this is actually a little bit easier. For a step-by-step method, the first thing we're going to do is what we've been doing all along is to find the least common denominator. So if we look at number 1, I think we agree that the least common denominator is 6. And what we're going to do with the LCD is to multiply each term by the LCD.
Mom.
And if we multiply each term by the LCD, so we have here like a 6, a 6, a 6, and what we do is half of 6 of course is 3, a third of 6 is 2, here the 6's cancel all together, so x equals 5. Done. So after we multiply each term by the LCD, we're just going to solve it like normal. Okay, the next one here is a little bit harder. So we have multiply each term. We agree that the LCD here is 6. 3 goes into 6 2 times, so 4y. Here the 6's cancel, and I have to be careful because I have to distribute the negative. Minus y minus 3. And here 6 times 2 is 12. So here we have y minus 3 equals 12, so y is 15. Okay. And what we have to remember is that we'll have to check our answers. It's not going to be a big deal when it comes to... Okay. So then this one here, we're going to multiply each term by 12. 12, 12, 12. So 3 goes into 12 4 times, 4 goes into 12 3 times, 2 goes into 12 6 times. I have to be careful though because of course I have to distribute the 4. And here remember this is actually going to be a negative 3. So if I distribute that, negative 3x plus 12 equals 6. So 5x plus 16 is 6 and 5x is negative 10. So x is negative 2. Okay. So far we haven't really had to check our answers, but starting with number 4, we want to be mindful of what we call our excluded values. So before I even start this problem, I'm going to make myself a little note that m is not allowed to be 1 and m is not allowed to be negative 1, because either of those answers would give me 0 in the denominator. I know my least common denominator is m minus 1, m plus 1, m minus 1, m plus 1. So now I can go through, of course that cancels, those are the same thing, the m minus 1 cancels here and the m plus 1 cancels there. This one is a little bit tougher here because here I actually have a FOIL problem. So I'm going to FOIL that in my head here, 2m squared minus 3m minus 5. And then here when I FOIL it is 2m squared plus 3m minus 5. We've got things that cancel out on both sides, the negative 5s, the 2m squareds. This is going to be 10 equals 6m, so m is 5/3. It didn't turn out to be quadratic, kind of lucked out there that it canceled, but sometimes it will turn out to be a quadratic after you've cleared the fractions. Okay, here's the next one. X squared minus 16, of course, is our least common denominator, so we're going to multiply each term by x minus 4, x plus 4, x minus 4, x plus 4, x minus 4, x plus 4. So here this is going to cancel, we get 12. X minus 4's cancel, so we have the negative 24, so negative 24x minus 96. Now here this is going to be 3x squared minus 16. This is not going to drop out, the quadratic, so it's going to become a quadratic equation. 12 minus 96, what's that, negative 84, 24x minus 84. So 0 equals 3x squared plus 24x, 84 minus 16, so 84 minus 16, let's see, is 68. Now we can divide everything by 3 here, again because it's an equation. Oh no, we can't, right? I guess we have to like factor that then. That's not going to be fun. Did I do that right? I feel like I maybe didn't do that right. 96 minus 12 is 84. 84 minus 16, no, that's 68. 3x and x, what multiplies to 68? Great. Okay, I'm going to have to come back to that one. I'm stuck on that one. Over here, we're going to multiply everything by 12, 12, 12, 12. Now this one's going to be different because it's got an inequality there. 2t squared plus 3t minus 6 is less than or equal to 4t plus 4. So this is a quadratic inequality, which we did a while back, right? 2t squared, when you subtract 4t from both sides, is minus t minus 10. Ugh, another hard one to factor. This one I can make it through, I bet. So this one here, let's see, multiples of 10. So this is going to be negative 5 and positive 2. Now remember with our inequalities, how we did them was on the number line. So here we get kind of that 5 halves, a negative 2. And we're going to do the circles, closed circles here on negative 2. And then 5 halves, or 2.5. And that gives us 3 chunks where we would test numbers in each chunk, and if it works, we shade. But you might remember the pattern. Anytime it was less than or equal to, it was always in between. So our final answer here would be negative 2 is less than or equal to t is less than or equal to 5 halves, like that. I guess I'm back on this one here where I'm stuck on the factoring. Has anyone gotten it? Let's see, 68, I'm going to do it old school way here. 68 divided by 2 is 34, so it's either going to be 2 and 34, or like 4 and 17. So is that going to work? 4 and 17.
Mom, I can't turn
You probably saw my mistake a long time ago. This should have been a 48.
Mom, I can't turn the sounds off.
So 48. So this should have been 84. I felt like that was a mistake. So this is 36. So it is divisible by 3. That's what I thought. So here this is x squared plus 8x plus 12. So this is x plus 6, x plus 2. So I'm going to get 2 answers, negative 6 and 2. Negative 2. Now I'm okay with both of those answers because back at the top, just reminding myself, the excluded values here would be 4 and negative 4. So let's say one of my answers had turned out to be 4, I would eliminate that answer. Or if I had gotten a 4 and a negative 4, it would have been empty set. Okay. Hopefully we're good on that, and we can obviously clear up any questions tomorrow.